Okay, let's start 3.7, implicit differentiation. Okay, so on Friday, we began implicit differentiation. What is, can somebody give me an example of an equation that is explicit? Explicit. Y equals 2x minus 5. If it's solved for y, it's explicitly written in terms of y, whereas now we're going to solve things that are, or we're going to derive things that are implicit. And the first problem I'm going to do for you is problem number 5. And problem number 5 says x squared plus y squared is equal to 1. And let's just recall how we do this. The first step to this process was we don't solve for y, we just take the derivative of each, okay? Do you remember what the derivative of x squared is? 2x plus 2y times y prime. So for those people who were not here on Friday, we learned why that happens. But basically, if you're taking the derivative of y with respect to x, every time we take the derivative of something with x, we just do it like normal. But when we take the derivative of something with y, we have to attach a y prime onto it. Equals what? 0. The derivative of 1 is 0. So when I took the derivative of this, the derivative, I got that. And if I solve for y here, or I'm sorry, how do I solve for y prime? I subtract my 2x, 2y times y prime is equal to negative 2x. Divide both sides by 2y, and you get y prime is equal to negative x over y. Piece of cake upside down. Okay? Try number 6 on your own. Go. Try number 6 on your own. Okay, everybody, let's come back. Hopefully you got that figured out. It should be very, very similar to your previous problem. The only difference, you should have a positive xy. That should be it. The derivative should be x over y. I'm sorry. Yeah, positive x over y as opposed to negative. This is number 8. I'll do number 8 for you. It is similar to some others. And 8 reads as follows. X squared minus 2xy plus y to the third is equal to c. Anybody want to guess what c is? C is just some constant. Might as well be 6, 9, 8, 24, 83, 3.141. When you take the derivative, you will get 0, okay? So if we were to take the derivative, we would get, let's see, d. The derivative with respect to variable x is going to be equal to, what's the derivative of x squared? 2x. I'm going to skip this middle part there because that looks kind of confusing. So I'm going to go, I'm going to move along a little bit here. Equals, what's the derivative of c? 0. And what's the derivative of y to the third? 3y squared y prime. Minus, I'm going to have something something in the middle here. What? How do I take the derivative of 2xy? I have two variables together, so therefore I need to use the product rule. Yes. No, it's not too bad, is it? No, it's really not. So I'm going to identify this. I'm going to use the subtraction sign in front, and I'm just going to identify 2x as one function, that will be f, and I'll say that y is my other function, which would be, say, g. I'm going to put the negative out front. So I'll use my parenthesis there. So the product rule says the derivative of the first, which is, I used up my negative in front. So 2 times y. So the derivative of f times the second left alone plus the derivative of the second. What's the derivative of y? Y prime times the first left alone. And that's it. I mean, we kind of freaked out about it. It really isn't that bad, is it? The product rule is actually pretty nice. If there's one I don't like, I guess it's probably the quotient rule. I get tired of that one. But the product rule is pretty nice. So if I simplify this even further, I get 2x minus 2y minus y prime times 2x plus, I'll write it, y prime times 3y squared equals 0. Now, what makes this problem unique compared to the others is that I have multiple y primes. So what do? Gather everything that doesn't have a y prime on one side, everything that does have a y prime on the other side. So it looks like I have a negative y prime times 2x plus y prime times 3y squared equals what? 2y minus 2x? Okay, so I moved stuff over to the other side. Now what should I factor out? That's the magic. If I factor out a y prime, I get a positive 3y squared minus a 2x. I just equals 2y minus 2x. Right here. I have the negative 2x right there. I have the positive 3y squared right there. And so now what should I do? Divide what? And if I do that, 3y squared minus 2x, and I get y prime is equal to 2y minus 2x over 3y squared minus 2x. And so now my derivative, yes, it's written in terms of both x and y, but we've, that's the nature of implicit differentiation. No, they are married. Can't cancel off the two x's, right? So yeah, why don't you try number 7 on your own? Go ahead, try 7. Okay, boys and girls, number 12, number 12. Shh. Write down number 12. All right, we have 1 plus x equals sine of xy squared. There's only one thing that makes this a little bit more complicated. Could somebody identify it? It would be the sine of, I'm going to have to use the chain rule, which is a beautiful thing. It works out very well. It is. If I take the derivative of this, the derivative is going to be equal to, what is the derivative of 1? 0. Derivative of x? 1. So I really don't have much more I have to do. Okay? I just have to find the derivative of this guy. Well, I should probably set up some boxes here, so I'm going to. This might not be correct notation, but I think that this will be the way you guys understand it best. And I'll just always call it like this. We'll say f of u, u of x, f prime of u, u prime of x. Sean, does it sound like I'm saying fu when I say, yeah, yep, yep, happens all the time. I just wait for the most immature one in the group to bring that up first. So now it's out in the open. So we can all remember Sean brought that up. So, all right. so really, f of u would be my inside function. And note, you guys, this is not a function. This is not. But for the nature of what we're doing, I'm just setting up like this, okay? Inside, outside, so on and so forth. So what's the outside? Sine of u. What's the inside? Xy squared. Very good. What's the derivative? Cosine of u. Derivative of xy squared, I have to use the awesome. Product rule of xy squared, no problems. Derivative of the first, which is x, or which is 1 times y squared. So as Ashley said, we got y squared plus, what's the derivative of 2, or what's the derivative of y squared? 2y, 2y, y prime times my x. So my whole derivative, remember, we got to substitute the u back in. We have y squared plus 2y, y prime x times cosine of xy squared. And that's equal to 1. What do you want? Well, it's right there. Well, right. It says 1 equals. I mean, we're not done. We got to solve for what yet? We got to solve for y prime. So that's what we want to get at. So I'm going to distribute here. What's that? I'll show you. Next problem. No, I don't want to do that. You can write that down. My first experienced student teaching, my teacher told me. My teacher told me, he said, you have a little bit loud of a calculus class, 6th and 7th hour. He said, here's what I'm going to tell you. He said, sometime if they just get too loud, he said, just start writing and stop talking. And after a while, they'll realize they don't know what's happening on the board. And so I did, I was just trying to be a nice guy, so I never really did that. But then they really agitated me one day. So I just kept writing, and it got more quiet. It was just complete silence, and then they're all whispering, like, what is he doing? And then at the end, I wrote quiz tomorrow, circled it, said, walked out the door. And they, they just freaked out. They just freaked out. But I didn't have the heart then to give them the quiz. I probably should have. So, so shh. Let us focus to the task at hand. Here's all I did. I distributed. I took the cosine of xy squared. I distributed it to y squared and a 2y prime x. I get this. I distributed the cosine of xy squared to both pieces. I did it because I want to get y prime by itself. Now this is not going to be a problem. everybody could see here, if I subtract this and then divide by that, I'll be good to go. What's that? This one? I just rearranged it so it looked nicer. Nope. The answer, we're almost there. 1 minus y squared cosine of xy squared is equal to y prime times 2xy cosine of xy squared. Now what should I do? Yeah, now if I divide, I'm good to go. And I would get y prime is equal to this 1 minus y squared cosine of xy squared divided by 2xy cosine of xy squared. No, you can't just cancel off the cosine of xy squareds. But that's y prime. Now, why don't you try problem 11? Try problem 11. You guys, try problem 11. Note that when you do 11, you do have to use the chain rule when you take the derivative of sine of y. The derivative of sine of y is not cosine of y. You have to use the chain rule. When you take the derivative of sine of y, you have to use the chain rule. And if you don't know it, I'll set it up. Why don't you start problem 11? Okay, this is the last thing I want to do today. So we've done examples very similar to what you see in your homework assignment. And you guys, I just want you to know I'm really trying to over prepare you for what you need. Okay. I think that there will be that time where you encounter some of the stuff in college, later on in calculus, where you'll say, I'm glad we tried some of the harder problems where your peers are struggling. But problem 27 says that if you have this curve, x squared plus y squared equals 2x squared plus y squared minus x quantity squared, that you want to try to find an equation for a line tangent at the point 0, 1/2. So Ashley asked, why use it? Well, this is one example why implicit differentiation works really well. Is because when we could do it instead of solving for y, which is nearly impossible in this scenario, it would take us a long time. It would be very difficult. We would get very upset at one another. Instead, I'm just going to deal with this, okay? And I'm going to do it implicitly. Now, what you got to do is, I know it's hard for you guys, but you have to do this. You must slow down, look at the problem, see it all the way through, trust what you know about the product rule, the quotient rule, chain rule, things like that. It'll work out. So we go slow. What's the derivative of x squared? 2x. No problem so far, right? What's the derivative of y squared? Any problems so far? Equals. Now, something should click in your mind right now. You should think chain rule. So I set it up. All right. I will say f of u, u of x, f prime of u, u prime of x. And note that this is notation that is technically not correct because this is not a function, but we're just using it because we're used to it. So what goes here? U squared. So I have something being squared. What is that something being squared? 2x plus 2y squared minus x. Okay. This is easy to take the derivative of. What's the derivative of u squared? 2u. You know what? This isn't that bad of to take the derivative of either. What is it? 4x plus 4y y prime minus 1. So it looks like if I identify the derivative, it will be u prime of x, which is 4x plus 4y y prime minus 1 this is my u prime of x times f prime of u. So times 2 times watch this. I'm not going to solve for y prime until I plug something in. Watch how great this is. My point is 0, 1/2. I have an x value. I have a y value. So I will plug them in. What is 2 times 0? 0 plus, what's 2 times 1/2? 1. So I just left with y prime on that side. Equals, what's 4 times 0? 0 plus, what's 4 times 1/2? So 2y prime minus 1 times 2 times, what's 2 times 0? 0. Let's see. Wow, what's 1/2 squared? 1/4, so that'll give me 1/2 minus 0. Okay, well, that'll help me out a little bit. I just plug my x's and my y's in. Now I'll work with the y prime. So y prime is 2y prime minus 1, that quantity, times, what's this right here? 1/2 times 2 is, so y prime is equal to, we said that was 1, 2y prime minus 1. How do I solve for y prime? Subtract the 2y prime over. I get negative y prime is equal to negative 1, so y prime is equal to 1. Done and done. I will. Wait. You want a work day on Wednesday? You want it tomorrow. I can't give you tomorrow and Wednesday.